everybody and welcome back to another video by Funlearn Tutorials. Now today we'll be looking at a particular sum. So we'll be looking at the ISI 2016 PEA Sum number 26. So let's first see what the sum is all about. So while reading the sum, we find that we have a function f. So let f be a function which maps R2 to R. So it's a two-dimensional real plane to the one-dimensional real plane be a function for every xyz belonging to capital R, that is the set of real numbers. We know that fxy plus fyz plus fzx equals 0. So they have given this. Now then for every xy belonging to R, they want us to find the value of this expression. So they want us to find the value of fxy minus fx0 plus fy0. Now the first thing that we usually need to do for these sort of sums is to find out what is f0, 0, because usually that is helpful. So what we'll do first is, let's look at this expression that we have. So let me just highlight this expression because we'll be coming back to this expression again and again. So what we'll be doing is, we have this expression fx, y. So we have fx, y plus fy, z. So fy, z, and we have fz, x. So we have fz, x. So they have said that this sum fx, y plus fy, z plus fz, x equals 0. They have given this. Now, as I said before, the first thing that we usually need to find out, I'm not saying it's for every sum, but usually what we need to find out is the value of f0, 0. So what we'll be doing here first is, we'll put x equal to y equal to z. So we put x equal to y equal to z equal to 0. What that gives us is, if we put x equal to y equal to z equal to 0 in this expression, we get f0, 0, because x and y are both 0 as per our assumption. So we get f0, 0, plus again, since y and z are also 0, we get f0, 0. So we get this. Then again, since z and x are both 0, we get f0, 0. Right, so we have f0, 0 3 times, that is equals 0. So what we can do is, we can simplify this. So we can simplify this and we can write 3f0, 0. So we can write 3f0, 0 equals 0. Right, so we can write that. Then automatically we can say that f0, 0 is actually 0. Right, so f0, 0 is actually 0. Now when you get this solution, it may feel like, did we actually have to do this entire calculation to find that f0, 0 is 0? Thing is, for this particular example, you get f0, 0. It sounds a very obvious answer, and it may feel that it is very obvious that we would get this result, but it is not so. There may be other functions where you may not get this result. So it's always better to check. So what we have is, let me just change the color. So this is the first thing that we have. You don't need to do it as per the steps, because ISI is an objective examination. This part, PEA at least, is an objective exam. But so we have this is the first step. Now let's go back to what we had. So we had fx, y minus fx, 0 plus fy, 0. Now if we compare, this expression to this expression, we can say that fx, y is the same for both these expressions. Then we have fx, 0. So we have fx, 0 and we have fy, 0. Now how can we convert this expression that we need to find out the value of to this expression? So we somehow have to change this expression to something. So what we can do is, let us write this expression again. So we had, let's check once again, we had fx, y plus fy, z plus fz, x. Right, so we had fx, y. So we had fx, y plus fy, z, fy, z plus fz, x equals 0. Right, that is what we had. That is what I had highlighted in yellow. Now what I would like to say is, if you can see, fy comma 0, fx comma 0, the only alphabet, the only algebraic alphabet that is missing in this expression when I compare it to this expression is z. So we don't have any z here. So the first thing that we can try is to put z equals to 0, right? So we can put z equal to 0. So let's see what that gives us. So we take z equal to 0. So we have fx comma y, we have fx comma y plus fy comma 0, we have fy comma 0 plus fz comma 0, sorry, f0 comma x, right? So we have this. Now let's see, let's go back again to what we needed. Fx comma y, fy comma 0, f0 comma x. What we needed to find out is fx comma y, we have this term, fy comma 0. Look at this last term, we have this last term as well. We have fy comma 0 as well. The only thing that we need to find out here is minus of fx comma 0, minus of fx comma 0, whereas we have f0 comma x. Okay. Now, since we have two x's, okay, here we have two x's and two y's, but the difference is fy comma 0 has a positive sign. So this is pretty much safe to assume that we need to do something with y, right? So now what we can do is, let's try this. Let's now put y equal to z equal to 0. So it actually follows from the previous expression. So I'm just writing 0 again. So what we can have is fx comma 0. So we can have fx comma 0. Why I did that is because the other expression that we had, this expression is fx comma 0. So I had this thing that why don't I put y equal to 0 and see what turns out. So what I did is fx comma 0, then I have f0 comma 0 again here. So since y is 0, so f0 comma 0, and then we have f0 comma x, because it's just zx and z I had taken to be 0, so this part remains the same. So we have f0 comma x. So what do we have here? We have fx comma 0 plus f0 comma 0 plus f0 comma x, right? Now we can use something that we found out earlier. So we found out that f0 comma 0 is 0, right? We found f0 comma 0 is 0. So this part f0 comma 0 is actually 0. So we can safely write that fx comma 0 plus f0 comma x is 0, right? So we can write fx comma 0 is equal to minus of f0 comma x. So we have fx comma 0 equal to minus of f0 comma x. Or what we can write is, since in this expression we had minus fx comma 0, I can very well write minus fx comma 0. So I could have written minus fx comma 0 is equal to f0 comma x, right? So now the next thing that we have is that this expression that we have, what I can do is I can use this relation. So instead of writing fx comma 0, I can write minus of f0 comma x. So what I'll be doing is I'll be using this expression and I'll be replacing it over here. See, fx comma f0 comma x is actually minus of fx comma 0, right? This actually means f0 comma x, this actually means f0 comma x is minus of fx comma 0, fx comma 0. And what happens if I put it there? So if I do this, if I actually put f0 comma if instead of f0 comma x I put minus fx comma 0, I get fxy plus fy0 minus fx0. What did we need to find out? The exact same thing, right? So essentially I have to just replace this expression with this expression, and this is the expression, then that will be the expression that I wanted, right? If I just put this expression, over here, this expression, then that is the expression that I wanted. This is the expression in my question. So the right hand side does not change. I just replace this term. The right hand side does not change, which means the answer will be 0. So here the answer is 0. So as per the information they have given us, if fx comma y, sorry, the highlighter changed, or maybe just this shifted. Anyways, So if fx comma y plus fy comma z plus fz comma x is 0, then we find out that fx comma y minus fx comma 0 plus fy comma 0 is equal to 0. So this is how we solve ISI 2016 PEA sum number 26. And if you like this video, then do subscribe to this channel, like this video, share it among your friends who are probably aspiring ISI students that they would like to crack the examination. Till then, happy learning.